Hello there. In this video we're going to talk about graphing rational functions. Now there are more complicated ones than what we're about to graph, however this will give you the basics that are required to start any study of graphing rational functions. So here we go. Let's first describe what exactly is a rational function. Well, a rational function is a function where the unknown is in the denominator of a fraction. So here are a couple examples. Okay, here's the most basic, y equals 1 over x. Of course, they could also use function notation and have one that looks a little bit more complicated, such as this. Now, right now, we are only going to study ones where x is in the denominator. We will not have any in the numerator for now. Now, how to graph these is several steps, but once you practice it a few times, you'll find that it does become significantly easier. So, let's begin. So, my generic form is y equals a over x minus b plus c. Alright, so the first thing I'm going to do is locate the vertical asymptote. Okay, now remember, an asymptote is a line that a graph approaches but never touches. Okay, and x equals b will be the equation of the asymptote in this form. Essentially, you're going to set the bottom equal to 0 and solve it. Okay, remember we have an asymptote because that is where the function is undefined. Okay, so once we know where that is, okay, then I'm going to plot a few points. These are our guide points. These are what we're going to use to actually draw the shape. Okay, those points are 1 over a, 1 comma a, a1, -1, negative a, and negative a, -1. Now, this will make sense because because we plug in 1 and we get a out of the equation, and then we plug in a and we get 1 out of the equation, and so forth. Okay, this will make sense when we work through an example. Okay, now I note that, hey, we may need to adjust this, as in reflect if a happens to be a negative number. Well, we'll do that as a separate step as part of the transformation. So that's why I say step 3 is reflect as needed. Okay. Step 4, shift horizontally as needed. Step 5, shift vertically as needed. Step 6, I'm going to draw in my vertical asymptote and my horizontal asymptote. The horizontal asymptote is essentially the vertical shift. Okay, and then for the 7th step, I actually draw the graph. Alright, so you're welcome to go back and pause any of this and copy what you need, or review it. However, we are going to move on. So, here's another look at the bottom part. Alright, so example 1. I have the equation f of x equals 3 over x plus 2 plus 1. So, my vertical asymptote I get by setting the bottom equal to 0. So, x plus 2 equals 0, subtract 2 from both sides, I get x equals -2. So, that means now I'm going to graph the parent function. I'm going to get those points that are going to help me graph initially. So the parent function is, notice that I kept the top number, but then it's just x on the bottom, and I don't care about what is being added or subtracted afterwards. So then, if I plug in 1, 3 divided by 1 is 3. If I plug in 3, 3 divided by 3 is 1. If I plug in -1, 3 divided by -1 is -3. Plug in -3, 3 divided by -1, 3 divided by -3 is -1. So, that gives me these 4 points And if you recall, this is the general shape of the graph of 1 over x. Okay, so these are my pilot points, if you will. Okay, those are going to be the ones that guide everything. So now it's time for me to transform those points. Okay, so I look back at my original equation, and just like before, left to right is shifted opposite the sign. So this is going to be shifted left 2, and then because this is plus 1, it's going to be shifted up 1. Okay. So I did list that. Now, the black points were my original points from the other equation. Sorry, from the other graph. Now, what you can see is that I took them, I went left 2, up 1. Left 2, up 1. Okay. Left 2, up 1. Left 2, up 1. And I plotted those in red. Now, I also plotted my horizontal asymptote. I was shifted up 1, so y equals 1, because it touches y, the y-axis at 1. And then it touches the x-axis at -2. So using those two dashed lines and my new points, I know approximately how to draw my curve. Now, in a second example, we're going to see one that requires a little bit more effort. Okay? But it's not super difficult at all. Okay? In this example, my top value is negative. So, okay, all that means is a minor adjustment of what we do. Okay? So I still look for my vertical asymptote right away, looking at the bottom. Okay, so I set the bottom equal to 0 and I solve. Now, it might not always be x minus or x plus. It could have a number in front of that. But it's no big deal. It just adds an extra step. We just have to multiply or divide to get x by itself. So, my parent function is, notice that I took the positive value of what's on top and then just x on the bottom. And then I followed that same pattern as before. 2 divided by 1 is 2. 2 divided by 2 is 1. 2 divided by -1 is -2. 2 divided by -2 is -1. So I plotted those just to give me a general idea of what's going on. Okay, now I'm going to do my reflection. Okay, now because that first number was negative, that means because the a value is negative, I need to reflect in the x-axis. Okay, then I'm going to shift right 5 and down 4. For the purpose of this example, what I've done is I've used two different colors. Okay, I reflected using one color, and then I did my horizontal and vertical shifts using a different color. Okay, so I started off by replotting my pilot points again. Okay, and then in red, I reflected in the x-axis. And I have to do that because A was negative. So I just took these black points and reflecting the x-axis, I just counted to it and then counted past it. So it took me one space to get there, so I went one space past. 2 spaces, 2 spaces. 2 spaces up, 2 more spaces up. 1 space up, 1 more space up. So the red points came from my reflection. Now, looking at my original equation, the x minus 5 tells me I need to shift right 5. And then the minus 4 tells me I need to go down 4. So, from these red points, I went right 5, 1, 2, 3, 4, 5, and down 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 1, 2, 3, 4. Same thing over here. 1, 2, 3, 4, 5. 1, 2, 3, 4. And down here. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so I plotted those points. Then I knew my vertical asymptote. What is that? X equals 5. So I drew that in. I knew my horizontal asymptote was that y equals -4. Drew that in. So then I knew how to draw my graph. I knew it would approach these two lines and go through these two pilot points. And that's how you graph rational functions. Okay. Feel free to go ahead and review this video, and we will be happy to take your questions in class. You're welcome to contact me with questions as needed using the typical methods as in class, and I will see you guys next time. Have a good night.